Well, hello. Today we're going to be talking about the metric system. Now, I particularly like the metric system. I know not everyone here in the United States does. I do. But I'll not share with you that I would much rather be on the metric system than the US customary system, but maybe I feel that way, maybe I don't. You know what? Let's just get started on it. I think the more you familiarize yourself with the metric system, the easier it gets, just like with anything. Every other country in the world uses the metric system, so this is definitely an example of something that if you ever leave the United States, you definitely are going to be using this. I think the history of the metric system is pretty fascinating. Most people don't. You're welcome to look it up. It is all based around base 10 ideas, and the there's a nice little acronym that goes with this, and I'm going to write one more thing in here. I'm just going to put in here base, um, something that doesn't have a prefix in it, like meter or liter. Those would be base units. Things like kilometer, kilo, or millimeter. Those have prefixes, and that changes the base unit of what you're talking about. So there's a nice little acronym that goes with this. It's just King Henry died by drinking chocolate milk. And anytime you need to do some conversion in the metric system, this is a great little acronym to use as you think about moving things around. Notice that all of these are powers of 10, meaning it's just moving a decimal. You don't have to remember, like what in the US customary system, if you want to change distances, you have to know, how many inches are in a foot, how many feet are in a yard, and how many yards are in a mile, or how many feet in a mile, like whatever it is you're going to do. But in the metric system, it's really just as easy as moving a decimal. So you can see that if we want to convert 4,200 centimeters into meters, first you can write these in order, and this is just like with our King Henry died by drinking chocolate milk, and I know we just write meters here, but this again is the base. And if we want to change it from centimeters to meters, notice that what we're doing is we're starting at centimeters and we're moving 2 places. And if you move 2 places, then that just means you're going to take the decimal and you're going to move the decimal 2 places to the left, the same way that you traveled here. See, we had 4,200 and you're like, but wait a minute, there is no decimal. Well, there's an implied decimal right there at the end. And so if you move this decimal 2 places to the left, just like we did up there, 1, 2, to right there, then what you end up with is 42 meters. So in other words, 4,200 centimeters is the same thing as 42 meters. Let's go ahead and use our King Henry died by the base unit. King Henry died by drinking chocolate milk. Let's go ahead and use that to make some more conversions. If we want to change 62 centimeters into millimeters, I can see that I'm starting out here at centimeters, and I'm going to go 1 place to the right. So I'm going to take the decimal that would be here, 62 point, and I've got to move it 1 place to the right. Well, in order to move it 1 place to the right, I actually have to put something else there. I'm going to put a 0. Like you could say 62.0, and it's really the same amount. It has a different level of precision, but so 62 centimeters becomes 620 millimeters. No worrying about fractions, no worrying about conversion factors and any of that other stuff. It's just moving a decimal. For the next one here, we've got 6,804 meters. Notice there's no prefix. That's just meters. So we're going to start here at meters, and it says we want to turn it into kilometers. So we're going to go all the way over to there. So I'm going to move 1, 2, 3 places to the left. So we start right there, and we're going to move 1, 2, 3 places to the left, and that gets me 6.804 kilometers. So just 3 places to the left. The next one, we want to change meters into centimeters. So we'll come back up here. meters, that's our base unit. We're going to go 1, 2 places to the right. So I'm going to take my 3.21 and go 1, 2 places to the right. That turns it into 321 centimeters. 260 centimeters into meters? Well, that's actually just the opposite of what we just did. We're going to go centimeters over to meters. That's 2 places to the left. So we start it there, and we end up at 2.60. Or just 2.6 would be fine as well. All right, the last two of these, and then we're going to get into some word problems here. 4.21 hectometers, one that's not often used. At least we don't use it as much here in the States. I don't know if they use it around the world as frequently as we do. So we're going to start here, and we're going to go over to dm. Now, notice that we have deca and decimeters. I know you can't tell that from here, but this goes kilo, hecto, deca, and so that's why it's DAM. This is decameters, this is decimeters. Okay, so when we want to go HM to DM, we're going to go 1, 2, 3 places. So then we move this decimal 4.21, we move it 1, 2, 3 places. That gets us 4,210 what's now become decimeters. The last one that we have here is centimeters over to decameters. Start here, and we go 1, 2, 3 places. So 1, 2, 3 places, that's 0.4568 decameters. All right. Let's start looking at some context problems, right? Some contextual problems, I guess. A piece measuring 142 centimeters is cut from a board that's 4.2 meters long. So notice we have a difference here, different units. Find the length remaining. Now, it's probably going to be easiest if we change everything into centimeters. You absolutely could change everything into meters. Either way we go about it, you've got to convert everything into the same unit. So let's take our 4.2 meters and let's turn that into centimeters. And if you look back up at your King Henry died, you'll see that we got to move 2 places to the right. So this will turn into 420 centimeters. Now we can take 420 centimeters and we'll subtract off 142 centimeters like this. We'll do a little borrowing. Okay, so we'll come through here and make that 1. We'll make that 10. And now I have 10 minus 2 is 8. And I'll have to borrow here. That'll become 3, and that's 11. So 11 minus 4 is 7. 3 minus 1 is 2. 278 centimeters. Please remember your label. Don't forget it. That's an important deal right there. All right. A bookcase is 175 centimeters long. It has 4 shelves. Find the cost of the shelves when the piece of lumber is $15.75 per meter. Okay, so it's $15.75 per meter. Now what we're going to do here is we have to figure out how to pay for these 4 shelves. So the first thing I might do is I might think about this. I'll take 1.75. Oh, you know what? I just kind of did a conversion without telling you guys. I changed it to meters. Let's take 175 centimeters, and we'll take that times 4. Okay, because there's 4 shelves. All right, now we have 700 centimeters is how much wood we need to make these 4 shelves. We need to go to the lumberyard and say, we need 700 centimeters of wood. And they would probably say, oh, that's silly. 700 centimeters is equal to just 7 meters. That's probably what they would say. They'd say, we sell wood by the meter. So if you need 700 centimeters, let's convert that centimeters up to the base unit of meters. So now we'll take 7 meters, and notice that it says $15.75 per meter. Actually kind of looks like that, right? $15.75. The word per, that means put the division there, turn into a fraction. And then we can, oh, computer. All right, now we can cancel out labels. And all I've got is 7 times 1575. Okay, you multiply that out, that should get you $110.25. And that's how much you're going to spend on shelving. There we go. Now, we just got done doing units of length, right? All of those that we just did were all meters. We had centimeters, millimeters, kilometers, right? A lot of people say kilometers. Now we're going to be changing over to units of mass. It's a lot like weight. You can see here that they're closely related, but once you leave Earth, your weight is different somewhere else, but your mass is unchanging. Mass basically means how much stuff makes it up. Weight is how is that stuff affected by gravity. Now, for the most part, all the problems that we're going to do take place here on Earth. So mass and weight, they're pretty much the same thing. Okay, if you really get into physics and get into the sciences, the other teachers would probably hate me for saying that, because once you get off this Earth or even far enough away from it to change how you're affected by its gravity, then it is different. But let's just count them as the same. Notice the base unit this time is gram. You've probably all heard of a kilogram, right? Or a milligram. If you've ever taken medication, it's probably in milligrams, most likely. The pharmaceutical industry is one of the industries here in the United States that's done a hard conversion, and all the medicines they sell are in the metric system so that they match up better with everyone else in the world. All right. We're just going to continue moving our units around. So we've got 7,421 grams to kilograms. So we start with grams, and we're going to move it 1, 2, 3 places to the left. So look at this, 1, 2, 3 places to the left makes 7.421. See, there's nothing new to learn. Sure, we did length a minute ago, and now we're doing weight. But man, it's the exact same procedure. It's not like you have to know there's 16 ounces in a pound, and I don't even know whatever you break down after ounces. You don't have to know all that stuff. You just got to know how to move a decimal. 43 milligrams to grams. So we're going from here over to the base unit. 3 places to the left. And now if I try to move this 3 places, notice that I've run out of places to go. I've got to put it over there. The only thing I can do is put in a place holding 0. So I get 0.043. We want to change grams to decigrams. Notice the same issue that we were having before with deci and deca, right? But we're starting with grams, that's the base unit, and we're just going to go to decigrams. That's just over 1 place. So move this over 1 place, and I get 4.5 decigrams. The last one of these, I'm going to go grams to milligrams. So 1, 2, 3 places, and then we go 1, 2, 3 places here. That's 45.6 milligrams. The cost of 3 packages of ground meat weighing 540 grams is, the 3 packages are 540 grams, 670 grams, and 890 grams. If the price per kilogram is $9.89, now I know you're like, oh my gosh, that's a lot. Well, there's about 2.2 pounds per kilogram, so just kind of keep that in mind. So if you were to buy 1 kilogram of meat, then that would be like buying a little over 2 pounds of meat. But it says round this to the nearest cent, and our price is in kilograms. So I'm going to take my 540, my 670, my 890. We're going to add them all up and see how much meat we're buying. Right? 4 and 7 make 11, and 9 makes 20. And we got to add up. Ooh, I'm going to put together the 2 and the 8 here. If I put those two together, that's going to make 10. Right? 10 plus 11 is 21. Looks like this. This many grams. Now that we have that many grams, let's change them over to kilograms or kilograms. I've got 2,100 grams, and when you want to change this over from grams to kilograms, 1, 2, 3 places, I got to move the decimal 1, 2, 3 places. And I know I did that kind of quickly, but I'm hoping that you guys know by now that there is no decimal there. It's just right on the right side. So I get 2.1. Oh, you know what? That's actually not my final answer. That's just 2.1 kilograms worth of meat. The next thing I need to do is I'm going to multiply that. I'm going to take that times the cost, which is $9.89 per 1 kilogram. So we do a little canceling, kilograms and kilograms cancel, and now I'm just going to take 2.1 times 9.89. And if I do that on the calculator, I should end up getting $20.77, hopefully. At least that's what I have in my notes here. I think I'm going to go ahead and check that just to make sure. Times 2.1. Yep, I got 20.769, but it said round to the nearest cent, so we would round it to 20.77. Now, so far we've done length, we've done weight, and now we're going to do capacity. Now, this oftentimes deals with like a liquid capacity. Whenever we see liters, people are talking. They typically talk about a liquid or a gas is usually the things that will be measured in liters. But really, it's how much space something takes up. Okay. All right. Let's go ahead and do some of these conversions. Guess what? They all convert exactly the same as what we've been doing, right? This is, man, if you can do meters to kilometers, we can do liters to kiloliters. So notice here this says we're going to go from milliliters to liters. Let's start here at milli, and we go 1, 2, 3 places to the left. So I'm going to go 1, 2, 3 places to the left, and now I've got to put some placeholding zeros in right here. Okay. That gets me, whoops, 0.0075 milliliters. Oh, sorry, liters. Now, if I want to change liters to milliliters, I'm going to go here. I'm going to go 1, 2, 3 places to the right this time. So 1, 2, 3 places to the right makes 37 milliliters. Change liters to cubic centimeters. Okay. Now this is one where I've got to go back up and show you one thing. I kind of blew past it at first because I wanted to show you how similar these were. But now I'm trying to change a liquid into more like a solid volume. Let's go back up and show you something here. This box right here, a milliliter is equal to 1 cubic centimeter. Okay, so that's what the volume of water. Now, the interesting thing about the metric system is that so much of it does come back to water. You can actually do conversions based on water. Like if you look at temperature, they set 0 where water freezes and 100 where water changes into a gas. Okay, they set. Oops, let's get up here. Okay, so they said we're going to take a box and we're going to make it however big it is. In this case, they're going to make this 1 unit, an arbitrary unit of a centimeter, and if you were to fill that up with water, we're going to call that 1 milliliter. So 1 cubic centimeter equals 1 milliliter. And one of the other interesting things is you can actually go between solid like this and a liquid and even weight, because 1 liter of water is equal to 1 kilogram of weight. And it's very specific water. It's like 1 liter of water at exactly 34 point whatever degrees Celsius. I'm sure that they have it in Celsius. But it's because that's where water is most dense. But they can actually connect these right back to water, which I think was very interesting. Okay, I took enough of your time here on the history, but this is our conversion we're going to use, is 1 milliliter equals 1 centimeter. So if we want to change 0.435 liters into cubic centimeters, the first thing we need to do is change this into milliliters. So we're going to change liters to milliliters first. So we've got liters, and we're going to go 1, 2, 3 places to the right. 1, 2, 3 places. So this becomes 435 milliliters. And now we know that 1 milliliter equals 1 cubic centimeter. So it's like a 1 for 1. So milliliters is cubic centimeters, so that's just the same. This is 435 cubic centimeters. Okay. And then lastly, 897 liters to kiloliters. We're going to start here with liters, and we're going to go 1, 2, 3 places to the left. So we do 1, 2, 3 places to the left, and that gets 0.897 kiloliters. Okay. All right. So one more problem on this page. I almost went to the next page here. A lab assistant is in charge of ordering acid for 3 chemistry classes for 30 students. Each student requires 80 milliliters of acid. How many liters should they order? So what we're going to do is to take 30 students times the 80 milliliters that each one of them needs, and that's going to be 2,400 milliliters. Now, once you know, oh, you know what? There's one more thing. 3 chemistry classes of 30 students. Whoa, that means I only did 1 class. 1 class needs this many. So it's this many for 1 class. Now we've got to take that times 3 classes. That will get us 7,200 milliliters total. The last thing that we're going to do is change this from milliliters into just regular liters. So we'll start here at milliliters, and we're going to go 1, 2, 3. We go 1, 2, 3. So that's 7.2 liters. That's how much we're going to order. Oh, but you know what? I almost bypassed it again. The assistant must order it by the whole liter. So we need to round that up. 8 liters. There we go. Now they can call and they can order the acid, and they will order 8 liters of acid. Okay, we can actually convert back and forth between the U.S. customary unit and the metric system. Now, for most of the things that you would do in math class, this would be given to you. You don't need to memorize this stuff. A lot of these are approximations. I still remember learning that 1 inch was 2.54 centimeters way back when I was in like sixth grade. My sixth grade teacher was Mr. Rinkenberger, and I still remember doing that. But it's okay if you don't remember those. Let's go ahead and do some conversions. Convert 55 miles to kilometers. Well, we have a nice conversion here, so we can use it. Let's use that one. I'm going to start out with 55 miles, and I'll put that on top, which means I've got to put miles on bottom for whatever my conversion is, and it just so happens that 1 mile is about 1.61 kilometers. It's not exact, but it's pretty close. So I'll put 1.61 up top, I'll put 1 mile on bottom, and then we'll do some canceling and canceling. And now we just have 55 times 1.61. Our only label that's left is kilometers. So I went ahead and multiplied that out on a calculator, and then we got that. All right, the next one here, notice they give us a rate. We have a rate. It says 45 miles per hour. So we'll write it like that. All right, well, I'm trying to get, I want to convert it into kilometers per hour. So if miles is on top, I'll put miles on bottom. It says I want it per hour, so I'm going to leave hours there. And I do have a nice conversion to go kilometers and miles, right? We just used it. 1.61 kilometers is 1 mile. Now we can cancel our labels, miles and miles, and the only labels we have left are kilometers, and we didn't even touch that one. It's still down there. It's just hours. So 45 times 1.61, and that's going to be kilometers per hour. When you multiply all that out, you should get 72.45 kilometers per hour. Okay, 2 more problems. 60 feet per second, 60 feet per second to meters per second. So we'll start out with 60 feet. It says per second, so that means we put seconds on bottom. And then if feet is on top, I've got to put feet on bottom. The next thing I'm going to do is go back up to my chart and see if I can go directly from feet to meters. If I can, cool. If not, then this problem gets a little bit harder. Let's see here. I have inches to centimeters. I have meters to feet. Oh, that'll work, right? It's not exact. It's pretty close, though. It says about 3.28 feet equals 1 meter. So it said 3.28 feet equals 1 meter. Notice that's why I put the labels on first, so I would know whether the number goes on top or bottom. Now I can cancel feet, and what I have is 60 divided by 3.28 seconds. We use a calculator on that. That comes out to 18.3 meters per second. All right, the last one on this page that we got here is gasoline is $3.89 per gallon. I need to find the cost per liter. So if gallons is what I want to get rid of, if gallons is on bottom, I'm going to put gallons on top because they have to be opposite in order to cancel out. Gallons is on bottom, I got to put gallons on top for my conversion. Let's go see what we can change gallons into. Let's see, gallon. Oh, here's one. Gallons equals 3.79 liters. 3.79 liters. Okay. So let's go back down here now, and we'll say that, oh, stop jumping around, computer. All right, so that says 1 gallon is 3.79 liters. There we go. Now we're able to cancel gallons And gallons cancels. Remember, you cancel bottoms and top. And what we've got is 389 dollars divided by 379 liters. And when you divide those out, we end up getting 1026. Now this is kind of weird. Gas, like you think money always goes to the nearest penny, but gas actually goes out to the nearest tenth of a cent, which is weird. So a lot of times you'll see this written like this at a gas station, 102 and 6/10 is how you would oftentimes see that written at a gas station. You might not notice it. They have teeny tiny little numbers in the upper right hand corner. Okay. All right, let's do just a few more. We've got about 6 or 7 more problems to do here, and then we'll be done for this. Okay. All right. Round each unit to the nearest hundredth. That's 2 decimals. It says find the weight in kilograms of a 45-pound person. So I have 45 pounds, and I want to get to kilograms. So I'm going to put pounds down here and kilograms up here. Now if you go back and check this, like I told you a little bit ago, 1 kilogram is about 2.2 pounds. So we can put 2.2 pounds and 1 kilogram. Pounds and pounds cancel. We have 45 divided by 2.2, and I think that one comes out nice. That will be, let's see here. Oh, I guess I need to grab a calculator and do it. So I've got 45 divided by 2.2. That would be 20.45 kilograms. So someone who weighs 20.45 kilograms will weigh about 45 pounds. Oh, I forgot my 1. I'm sorry. Let's try that again. There. Sorry, I actually have a line down my computer screen that sometimes prevents me from seeing things like that, as weird as that sounds. My screen is broke. Okay, now I get 65.91 kilograms because it says round to the nearest hundredth. There we go. That's a little better. Express 30 miles per hour in kilometers per hour. So 30 miles per hour. Remember, per means put the line. Just make that bigger. And we want to get to kilometers per hour. If miles is on top, I got to put miles on bottom. I'll put kilometers on top. And then remember that when we go back here to look, flip back 1 page, we're looking for this one right here, miles and kilometers. 1 mile is about 1.61 kilometers. So our miles cancels. Now I have 30 times 1.61, and that's just going to equal 48.3. 48.3 kilometers per hour. The next one we have is seedless watermelon. Costs 59 cents per pound. Find the cost per kilogram. So I'll start out with $0.59 per 1 pound. And I want to get rid of pounds. Right now, pounds is on bottom, so I'm going to put pounds on top and kilograms on bottom. We know that there's 2.2 pounds per 1 kilogram. So pounds and pounds cancels. what we've got is 0.59 times 2.2, and then that will end up being $1.30 per kilogram. Dextane costs $32.99 per gallon. Right, so as soon as we see the per, we draw the line, we put 1 gallon on bottom. And it says how much is the cost per liter. If gallons is on bottom, I got to put gallons on top. We always do the opposite. Wherever it is, it's got to be opposite if you want to cancel. And then we'll put liters on bottom. And we do have a nice conversion. I'm going to flip back here. We do have a nice conversion to go from gallons to liters. Right? It's right here. We've used it already. 3.79 liters are in 1 gallon. So put 3.79 on bottom and 1 gallon goes on top. And then we'll have, it's really just 32.99 divided by 3.79. So that gets me $8.70 per liter. Now make sure you're rounding correctly, because it's actually 8.704, which will round down. So it's $8.70 per liter. A man is 6 feet tall. Find his height in meters. So we start with 6 feet. There is no per this time, so I'll just put it over 1. If feet's on top, I got to put feet on bottom, and I'm trying to find meters. There is a conversion if you flip back to the other page, and it says 3.28 feet equals 1 meter. Feet and feet cancel. We get 6 divided by 3.28. And I get 1.829. But it says round to 2 decimals. So I'm not just going to put 1.829 and be like, well, I'm just lazy. I'll just make him grade it. No, it says round to 2 decimals, so I better do that. That's 1.83 meters. That's how tall this person is. Okay. As we're down to our last 2 examples, I think. On this page, that is, because there's actually a whole nother page. All right, so convert 200 meters to feet. Okay, so let's go ahead and we'll start with 200 meters, just like we were doing a little bit ago. Meters is on top. I put meters on bottom. We'll put feet on top. We know there's 3.28 feet in 1 meter. Then we multiply those and get 656 feet. The meters cancel. 45 centimeters. Oops. All right, so 45 centimeters. Put it over 1, just for good measure. Centimeters on top, so I'll put centimeters on bottom, and I go inches. If you go back and check up in that chart that we had on that other page, it said 2.54 centimeters is equal to 1 inch. So now the labels cancel, and all we're left with is inches. So we have 45 divided by 2.54, and that should get you 17.72 inches. So, all right, now we are on the last page of our notes, and I apologize because I thought I was done a little bit ago. Sorry to get your hopes up, those of you that are like, I just want to be done. You know what? You can just fast forward about 5 minutes, and then you would be done. Of course, you would miss all this great commentary on how to do these problems. 90 kilometers. Notice we have that line per hour. Okay, so we have the first one set up. We want to change it into miles per hour. So I'm going to start out with this. I have kilometers on top, so I put kilometers on bottom, and I'll put miles on top. Notice whenever I do miles, I don't put M. M is reserved for meters. So I use MI for miles, or you can write out miles, but don't just use M, that's meters. Then we know that there are about 1.61 kilometers in 1 mile. So this is the setup for that. Those cancel. Ultimately, what you're doing is taking 90 and dividing it by 1.61, and that will get you 55.9 miles per hour. You could even write mph there. But I like to write it like this, just because it reminds me that it's a rate, and that hours is on bottom. The next one is the price of gasoline is $1.12.5, $1.125 per liter. $1.125 per 1 liter. Liters is on bottom, so where does it go? Think about it. It's on bottom. It's got to go up on top. They always got to be opposite. We want to try changing it into gallons. And so we know that there are 3.79 liters in 1 gallon. 3.79 liters in 1 gallon. We can cancel liters and liters. And so if you take 1.125 times 3.79, I get 4.263. It says round to the nearest cent, though, so that means I better take this to 2 decimal places, and that will then just be 4.26. Because the 3 is smaller, so this will round down. Okay. This time we're going to be working with some weight. Right? Again, round to the nearest hundredth. Says that an 86 kilogram person. So we'll start with 86 kilograms. I'm just going to put that over 1 because it's not any kind of a rate. It just says it's their weight, right? 86 kilograms on top, so I put kilograms on bottom, and we're going to put pounds on top. And we know that there's 2.2 pounds per 1 kilogram. You got to keep going back and referencing your chart. So kilograms and kilograms cancel, and you take 86 times 2.2 to get 189.2 pounds. 30 meters per second in feet per second. So we'll do this, 30 meters. Oh, there's the per, 1 second. If meters is on top, think about where meters is going to go for the next one. I know you're getting tired of me saying that. Hopefully it'll stick. Meters is on top, then meters has to go on bottom, and we'll do feet up on top. Right, and we do have a nice conversion. It's 3.28 feet per 1 meter. Right, so we'll go meters and meters. And so we just take 30 times 3.28, and you get 98.4. feet per second. 5 kilogram ham costs $10 per kilogram. Find the cost per pound. So the interesting thing about this is there's extra information this time. There's stuff that we don't use. Notice this just says find the cost per pound. It doesn't say find the cost of the ham, or it doesn't, nothing like that. It just says find the cost per pound. Well, I know what the cost per pound is, or I know what the cost per some unit of weight is. It's $10 per 1 kilogram. Okay, notice I didn't do anything at all with that 5. And then what we're going to do next is say we want to get the cost per pound. Kilograms on bottom, so I'll put kilograms on top, and I'll put pounds on bottom. There. And now we do have a nice conversion for this. It's 2.2 pounds is 1 kilogram. So what we're going to have now is 10 divided by 2.2. Nowhere did I actually use that 5. This ends up getting me a cost of $4.55 per pound. It's a little pricey. Hope that's a really good ham. All right. I guess it depends where you are. A 2.5 kilogram bag of grass seed costs $10.99. Find the cost per pound. Oh, here we go. This time it doesn't give us a cost per pound. We know that 2.5 kilograms costs $10.99. Now, this might seem strange, like, well, how do you know which one goes on top? If I'm trying to find cost per pound, in the end, I want it to have money on top, and I want to have pounds on bottom, right? So if I want to end up having money on top, I'm going to put money on top right now. $10.99 per 2.5 kilograms. That's kind of tricky, so you might go back and listen to that again. Right? I want to end up with money on top, so I'm going to start with money on top. So it's $10.99 per 2 kilograms. Kilograms on bottom, I want it to cancel, so I got to put it on top. And then we know there's 2.2 pounds per 1 kilogram. When you look at what cancels, all that cancels, and so we have 10.99 divided by 2.5 times 2.2. Okay. So if you do all that, 2.5 times 2.2 comes out to be just exactly 5.5. So we have 10.99 divided by 5.5, and that comes out to be a nice one. $1.998. So when we round this to the nearest penny, as it would make sense, this is too big, so we'll go to here. So that means we have to round it up, and that then just becomes $2 per pound. Ooh, that's a lot of metric conversions we did today. All right, a lot of metric conversions, and then back to the U.S. and all around. So like I said, it's a pretty interesting how everything relates. It's a super easy measuring system. That's why it's used everywhere else in the world. Those of you that have come from other countries already know this, and you're like, oh my gosh, Americans, why don't you just learn the metric system? I mean, the big reason is ultimately cost. Like, we don't want to pony up, and plus people in America we're very proud of what we have, and they don't want to change. A little obstinate sometimes. But it would be a huge, huge expenditure to try to change everything around into the metric system. There's a lot of studies done on whether we should do it, whether we shouldn't. The U.S. government tried to make us do it some time ago, a couple different times. That's why the pharmaceutical industry went over. But interesting to some, maybe not to others. I hope this was beneficial to you. I hope this was helpful to get through these problems. Have a great day.